Welcome to this second session of the day. We're going to be talking about synergies between LISA and other facilities and physics. And I want to welcome Tyrone Woods. He is a Herzberg astronomy and astrophysics researcher at Victoria. And I would like to give you the floor. Go ahead, Tyrone.
Thanks very much, Liliana. And thanks everyone very much for having me and for the wonderful morning session, early session today that helped introduce everything. So I thought I'd kick off the sort of synergies session with other telescopes by talking about a big thing happening in Canadian astronomy. And if you haven't heard much about the CASTOR mission yet, I promise you're going to be hearing an awful lot about it over the next few years. There we are. So, what are the science goals, first of all? What are we trying to do with CASTOR? Well, if you look at it, we're looking to study Milky Way and Magellanic, reaching into the Magellanic Clouds, white dwarf populations. We want to study the growth of massive black holes over cosmic time, and particularly studying in detail the masses and the accretion physics of thousands of low redshift AGN. We'll be chasing after tidal disruption events and following up on gravitational wave transients, studying populations of interacting binaries, including stellar mass black holes. Powerful probes of dark energy and the expansion of the universe, measuring photo redshifts. I'm listing off CASTOR science goals, but I could just as easily be listing off, and in fact am, most of the LISA science objectives. In fact, SOs 1, 2, 3, 4, 6, and 8 of 8. And I can't remember what 5 and 7 are off the top of my head, but I'm pretty sure I could connect to them as well. So what is this CASTOR that I'm talking about? So it's the Cosmological Advanced Survey Telescope for optical and UV research. And so basically the idea is that there's been a huge swing in electromagnetic astronomy towards the infrared, and James Webb is revolutionizing astronomy as we speak. Euclid and Roman are going to be coming online in very short order. But humanity needs a powerful eye on the sky in the UV and blue. And CASTOR is what we think is going to be that bridge that we need in the post-Hubble era. So what we're talking about is something that's going to, a 1 meter telescope that's going to have Hubble-like resolution, just a little bit worse than Hubble, but over a, comparative to Hubble, enormous field of view, about 1/4 of a square degree. It's going to offer simultaneous photometric observations in the ultraviolet, in U band and in G band, roughly 150 to 550 nanometers. And it's going to be incredibly sensitive, with a 1 meter telescope and with a powerful, cutting edge teledyne detector. It's going to be able to reach AV magnitudes of 27 in 600 seconds, just a fraction of its hour and a half work. It's not going to be strictly a photometric mission, of course. We're going to have a GRISM spectroscopy filter available for the entire field in UV and U bands. And in a parallel field, we're also going to have UV MOS spectroscopy available for roughly the UV from 150 to 300 nanometers, medium resolution R2000. So if you're not coming in from an astronomy background, I understand we have a very broad interest in the LISA community in Canada. So just sort of for comparison, tiled here in red, this is from a very time-intensive Hubble legacy survey of just a portion of the Andromeda galaxy of M31. And here, in 6 pointings is what CASTOR is going to be able to do, study the entirety of the galaxy. Maybe as a little bit of an even easier reference, CASTOR's field of view is going to be roughly the size of the moon compared with Hubble's field of view, which is comparatively tiny. Just to sort of compare the resolution that CASTOR is going to be able to offer compared to previous wide field or wider field UV surveys missions. So GALEX, sort of previous flagship NASA wide field UV mission, compared here, by simulated deep field with this is an observed deep field with a simulation of what CASTOR is going to be able to do in the same deep field of galaxies. And you can see just so many things, so much more crisp and clear detail popping out. So it's really going to be can't stress this enough, a transformative engine for astronomical discoveries. We have a primary cosmology survey that I'll talk a little bit more in a minute, is going to be matched with the same, with the sort of overlap of the footprints between the Euclid deep surveys, LSST and Roman. We're going to have a target of opportunity photometric and spectroscopic observations. We can turn around and do follow-up within about 2 hours, almost all of the time. Just a few windows where it won't be so good. We're going to be able to offer high precision proper motion measurements, several magnitudes below what Gaia can do. Gaia can't really get down below 20th magnitude stars. Not as good as Gaia, but we can do much fainter. We'll have a high precision transit photometry instrument as well. We're baseline to a 5-year mission, but I really want to stress that this is for launch in the late 2020s. But I really want to stress that this is sort of a minimum. If it doesn't make it to 5 years, it's a mission failure, more or less. We really, there's no reason to expect that we can't get, significantly more, maybe order 10 years, maybe more, based on sort of the legacy. For instance, the Canadian bus that we're considering has been successfully used on other Canadian missions for, of order a decade and a half, and still going strong. Critically, I hinted at this a little bit earlier, but this is really a bridge, a pathway in the ultraviolet between the Hubble era, which is coming to a close. Unfortunately, it just can't go on forever. And every time that there's a new pause in operations, the astronomy community's hearts collectively stop. That can't go on forever. We need a new eye on the sky in the ultraviolet, and we also need, and NASA has identified, that it's a strong enough need that it's prepared to commit of order $800 million to this over the next 20 years or so, a technology pathway, raising the technology readiness level for UV instrumentation, among many other things, to build a pathway towards a 6-meter UVOIR telescope in the 2040s, LUVOIR or something LUVOIR-like, whatever acronym we're going with now. Somebody I'm sure can say in the comments. So there's a strong need for something like CASTOR, and I think Canada is uniquely well positioned to deliver this. Just a few of the going into detail on a few of the proposed surveys that CASTOR is going to be doing. So we have this primary legacy survey that's going to give deep UV, U, and G observations overlapping with the LSST wide, fast, deep survey and the Euclid wide field. Part of this is also going to be covered by the Roman ultra deep field. And here, just sort of for comparison, is what CASTOR is going to be, the magnitudes that CASTOR is going to be reaching relative to sort of all of these other flagship missions of the 2020s. So there are a number of proposed legacy surveys and expected GO programs as well. I should say this is not strictly a legacy survey instrument. There will be plenty of time for guest observer programs. Particular ones targeting the Milky Way and Magellanic Clouds that I think would be of great interest to the LISA community as well. So there's a galactic plane survey that's looking at targeting 1,000 square degrees of the bulge and inner disk, roughly tracing the Roman plane survey that's already planned. Providing photometry as well as GRISM spectroscopy and some UV MOS targeted. That's still sort of under discussion. We'd love to hear input on that. There'll also be surveys of galactic substructures, imaging dozens of stellar streams and clusters, and looking out into the halo as well. Very deep studies. Globular cluster surveys and nearby galaxy surveys as well, including, of course, the Magellanic Clouds, as well as M31, M33, and about 300 of the nearest galaxies. Here, I just wanted to show for comparison what CASTOR is going to be able to do. This is the same magnitude limits as before, but here overplotted on this. This is from a paper by student Nick Fanton, who just recently wrapped up here at UVic/NRC. Overplotted are the SEDs from 0.6 solar mass white dwarfs, relatively low mass white dwarfs, at 4 kiloparsecs, for different temperatures. And you see we're going to be able to beautifully characterize a lot of relatively distant white dwarfs within the Milky Way. So we're also thinking a lot already, frankly, about gravitational wave follow-up. Particularly in terms of LIGO transients like kilonovae. So first of all, just take a step back. There are definitely planned transient surveys for CASTOR, the cadence survey. There will be a number of surveys, co-programs, as well as a dedicated legacy survey for AGN studies, including an AGN reverberation mapping survey, and target of opportunity follow-up campaign. And I just wanted to stress here for kilonovae, you really need, at early times, you need fast response in the sort of relatively near, in the near ultraviolet, not so much the far ultraviolet, but that's where in the near ultraviolet, you have really powerful discriminating power between different models for composition and optical depth and sort of the nature of the explosion. So this is something we're really looking forward to. So what is the sort of planned schedule for CASTOR in terms of where we are at the moment? Well, right now we're in phase 0, so we're iterating between our university partners across the country and around the globe, as well as industry partners within Canada and the CSA and NRC to rigorously define the final plan for what the mission is going to look like before we proceed with funding and with development. Assuming all goes well, and right now it looks like there's no reason to think otherwise, we should be aiming for launch in, I would say, the late 2020s at this point. That's probably the most confident answer I can give without risking being off by a year here or there. But let's say the late 2020s, absolutely. And I should say that, well, this is firmly a Canadian-led flagship mission. We do have already substantive collaboration and expected concrete partnerships. These are still being discussed with India, with the UK, and with JPL in particular in the US. The door is still open, however, to other additional partners. So if you're coming from outside of Canada and are not from a country listed here, but would very, very much like to participate, please don't be afraid to reach out. So, it's a relatively short time frame here. We only have about 15 minutes, and I think I'm already a good chunk of the way through it. So I'm not going to go in detail over every possible synergy that CASTOR has with LISA, but I'm just going to kind of quickly enumerate a few of them. So, again, this is a powerful probe of galactic and Magellanic white dwarf and compact binary populations, providing a photometric and spectroscopic eye in the sky in the UV that's likely not going to be there otherwise. We're planning detailed surveys and detailed studies of galaxies in AGN, and detailed studies of crowded fields as well. After launch of LISA, and again, we do expect CASTOR operations after the launch of LISA. Follow-up of low to moderate redshift massive black hole binaries and their environments, follow-up of TDEs, extreme mass ratio inspirals, very excited about the prospect of finding intermediate mass black holes tearing apart white dwarfs and other exotic transients. And overall, complementary electromagnetic studies the whole way of the various binary populations that we'll be finding. I'll can really quickly whip through an example here, torn straight from the White Astro 2020 decadal white papers, but we heard a little bit about this earlier. LISA can localize a million solar mass supermassive black hole binary to within a few square degrees, weeks to months prior to a merger at redshift 1 to 2. That's big for CASTOR, but nothing we couldn't still search through. We expect UV signatures. Closer to the time of merger, the localization is going to get much better, of order 0.1 degree. That's totally fine, no problem at all. Post-merger, CASTOR can be there for follow-up as well. Just really quickly, I'll also say that as the phase 0 plugs along, we now are developing a number of tools for mission planning and exposure time calculators, image simulators. These are all being compiled on a GitHub anybody can access. They're also being complemented by GUIs that we're building that are available on the Canadian Astronomy Data Center's CANFAR platform, so that you can play around with it and look at what CASTOR can do for you. So I'll stop there and just say that if any of this interests you, and I certainly hope it does, please don't hesitate to join the CASTOR community. Just reach out anytime. We're an open collaboration. Look forward to hearing from you.
Thank you very much, Tyrone. Excellent talk. I really appreciate the opportunity to hear more about what Castro has to offer to all of us and the connections with Lisa. So I think we have some time for a question or two. Maybe somebody wants to jump in, or we can write a question in the chat.
Maybe I could ask one thing. Yeah.
Yes.
So I missed the, I can't keep the date straight. What's the
Sure.
latest date at which CASTOR is still taking data?
Is still taking data. So
Yeah, assume the 10-year.
Yeah. So if we make an end of 2027 launch date, which is sort of what was nominally discussed, that's if there is absolutely no slippage in funding, et cetera, in funding approval, things like that. Then, 5 years after that, so 2032 would be the very, minimum. That would be the worst case scenario that we're prepared to consider. But we think that had many discussions with PI Pat Cote, with engineers, with others. 2037 is definitely not even optimistic, I would say. That would be sort of baseline, and we would expect it to be still operating. I'm optimistic it could be operating even later. I think there's some CSA people on the call that will probably hesitate to make any kind of guarantee on that. But yeah.
Okay, thank you, Tyrone. There is a question in the chat. I don't know, Scott, did you want to have a follow-up, or you happy now?
I'm satisfied. So, I mean, it does sound like there is some likelihood of an overlap between the two missions.
Yeah, I mean, obviously, if Lisa continues to be delayed, or paradoxically, if CASTOR happens to be remarkably, the first mission ever super on time, then there could be some concern about overlap, but I'm not that worried.
Okay,
yeah.
Good. Okay, we have a question in the chat, and I think we have 1 minute to answer. So I guess I'm gonna go ahead, and it's by Jess. The question is, what are you most excited about for joining Lisa Castor Science?
I mean, that's a tough question to answer, but I threw up a science case about, if we can get a low redshift, moderately low redshift black hole merger that we can follow up all the way through. I think that would be really, really exciting. I'm also going way back, a big nerd for white dwarf binary populations, and so I would really love to get into the nitty-gritty following mass transfer in detail of some of these systems that Lisa is going to be finding and teasing apart what's gravitational waves and what's other components of mass transfer, and so and angular momentum breaking, and so from the nitty-gritty to big splashy once per mission events, I think it's all just going to be great.
No, this is really exciting. I think there is a lot of opportunity to keep building expertise, and it's really motivation for younger people that are joining the community. So Jess has another question. I think, okay, Maria is answering also, contributing there. I'm gonna let you guys read in the chat. And I thank you very much for your talk, Tyrone. Yeah, I'm gonna ask our next, thank you. Our next speaker is Nahi.